Same prices, same rules. Ignore the fee, and greedily grabbing every upward move promises $13 of profit. But charge just $2 per trade, and that answer quietly becomes wrong. The real maximum is only 8. One tiny fee reshapes every decision. This buy and sell stock with a transaction fee, the gentlest variant in the whole family, and a clean note to end the module on. Unlimited transactions, but each one costs a flat fee. The change, as you'll see, is a single subtraction in one transition. Here is the setup. You're given an array of prices and an integer fee. You may buy and sell as many times as you like, but every completed transaction costs you the fee. Your job is to maximize total profit, net of fees. Take prices 1, 3, 2, 8, 4, 9 with a fee of 2. The best plan buys at 1 and sells at 8, then buys at 4 and sells at 9. 2 trades, 2 fees. Notice the small wiggle from 3 down to 2, then back up, isn't worth touching. The fee eats any tiny gain. The state is exactly the one we've used all module. Let f of I, hold, be the maximum profit from day I onward, where hold is 1 if we currently own a share and 0 if we don't. 2 situations per day. Nothing new here yet. So where does the fee go? It's a constant, charged exactly once per round trip. We'll charge it on the sell. Charging it on the buy works just as well, as long as you pay it exactly once per completed transaction, never twice. Now the transitions. When we're not holding, we either buy today, paying the price and flipping into the holding state, or we skip. When we are holding, we either sell today, collecting the price minus the fee and flipping out, or we hold on. That minus fee is the entire change from stock to. In code, it's almost invisible. We build a table with a base case of 0, then sweep from the last day backward. The not holding line is untouched. The holding line gains one term, minus fee, applied when we sell. The max operator does the rest, automatically refusing any trade the fee would be unprofitable. Let's watch the table fill for our example. We start from the end, where everything is 0, and move left. Each cell asks, is it better to act or to wait? Watch how the tiny 2 to 3 bump never survives, because paying the fee costs more than the gain. The final answer lands in f of 0, not holding $8. One last polish. Every column only ever looks at the column just ahead of it. So we don't need the whole table, just 2 little rows, ahead and current. Roll them forward, and the space collapses to constant. The scorecard is clean. One pass over the prices gives time linear in n. After the rolling trick, space is constant. And 2 pitfalls to remember. Never charge the fee on both buy and sell, that's paying twice, and trust the max to skip trades that the fee turns unprofitable. And that closes the module. 1 machine, 4 knobs. Every problem wrote the same holding state. Stock 1 capped it at a single transaction. Stock 2 removed the cap. Stock 3 and 4 added a counter dimension for a transaction limit. Cooldown shifted a transition's target index. And the fee simply subtracted a constant. Same engine, different settings. The reusable move is this. Encode what you can do next as states. Encode the rules as transitions. Then collapse the day dimension for space. Next module, we return to subsequences, but now optimizing length under an ordering rule, the longest increasing subsequence family. See you there.